Hello everyone, welcome to Sangam tutorials, Gubbi online classes for Ncert 10th standard and Cbse 10th standard for mathematics and science classes. So in this session we will be going with physics, that is light chapter. So in the last class regarding the mirrors we have discussed a lot of things. Among them the most important concept what we had discussed it was regarding concave mirrors. So you are in a position to answer what is a concave mirror, what are the characteristics of a concave mirror, and why it is called as a converging mirror particularly. That's very important, you know the ray diagrams. So now when we study regarding the images formed by the concave mirrors, when the object is placed at different positions from the mirror, we have ultimately got 6 beautiful ray diagrams. So among these ray diagrams, all the ray diagrams are very important. So among them, when the object is kept at infinity, first one, when the object is kept beyond C, when the object is kept at C, when the object is kept between C and F, when the object is kept at F, when the object is kept at F and P. So these are the 6 different ray diagrams we had done in the last class. So you have to practice all the ray diagrams which are very important. So among all the 6 ray diagrams, very important is the images formed by the plane mirror when the object is kept at F, between F and P, and at C. So these 3 are very much important at the point of view of your examination. So in today's class, let us recapitulate all the position and the image formed by the concave mirrors when the objects are kept at different distances from the pole of the mirror. So one by one we will study the characteristics of the images. So once we come across all the 6 at once, we can write all the 6 characteristics, that is the main 3 characteristics of the images formed by the concave mirrors. So let us go with the concave mirror. So you know that the concave mirror is a part of a hollow sphere which is silvered at the outer surface, hence it is reflective at the inner surface. So the center of the mirror is called the pole of the mirror. This is the center of curvature, and the line which joins the center of curvature and the pole of the mirror, which can be extended on both sides, is called as the principal axis. The point which is in between the center of curvature and the pole of the mirror is called the principal focus, that is represented by capital letter F. So here in the first case what we did is we kept the object at infinity. It was a point very far away from the mirror, that is pole of the mirror, as we know that everything should be measured from the pole of the mirror. So therefore the object was at infinity. So therefore the light rays which were coming from the object which is kept at infinity falls on the reflecting mirror and the image is formed. So here particularly the image is formed at the focus. So at this point the image was formed. So this was the ray diagram. I am not going to write all the ray diagrams here, just I will give you a bird's eye view regarding this. When the object is placed at infinity of the mirror, then the image will be formed at the principal focus. So when the object is brought nearer to the pole of the mirror, that is mirror itself, it is beyond C somewhere here. When you keep the object here at this point AB, right? So at this point, the image, the light rays which are coming from the particular object is going to get reflected by the concave mirror, and it is going to form the image, and that image will be formed between C and F somewhere here. So when you observe this, when you see this, the object is coming nearer and nearer to the mirror, whereas the image of the object is moving far away from the mirror, and also it is getting that is inverted, that is real and inverted images. So this is the point where, so this was the first point, so this is the first one, this is rated as second, this is the second position. When you bring the object still more towards the pole of the mirror and you keep it on the center of curvature of the mirror, again the light rays coming from the object gets reflected from the mirror, and they are going to form the image at the center of curvature. So at the center of curvature, when the image is formed, it will be exactly the same size as that of the object. So you can see the object is coming nearer and nearer to the mirror. The image is going far away from the mirror. So now when you keep the object in between C and F, somewhere here, if you keep the object in between C and F, if you keep the object, again the light rays coming from the object fall on the mirror and gets reflected. The image is going to form beyond center of curvature somewhere here. So the image is going to form here, in the sense the object is coming nearer and nearer to the mirror. The image is going far away from the mirror. So next, when you keep the object exactly at the focus, the image is going to be too far away from the mirror. Somewhere here it is going to form. So when you keep the object in between F and P at this particular point. So here for this, let us take it as third one. This is third. This is the third object. Its image is the fourth object, and this is the fourth one. We will take this as the fourth one. When you keep the object in between, that is F and P, the image will be formed beyond the mirror, which is virtual and erect. Image will be formed here. If you take it as the sixth point, you can take it as the sixth image. So here this is how it is formed. So as the object comes nearer and nearer to the mirror, the image of the object goes far away from the mirror. So in all the first five cases, we can see that the images are real and inverted. So in the only one case, in only one particular case, we can see that if the object is placed between F and P, then the image will be formed beyond the mirror, which is virtual, and erect, which is also enlarged. So it is virtual and enlarged. So in all other cases, either it is real and inverted, but it is at this point it is highly diminished. It is diminished. Okay, same size. It is enlarged. It is highly enlarged, and in this case it is virtual and enlarged. Virtual, erect, and enlarged. So this is the theme of the ray diagrams which are formed by the concave mirror. So here, one particular thing we can go point size. So real images are real, inverted, and diminished. So these type of images also we are going to get. So second point is that they are real, inverted, and same size, that is size of the object. So this is also possible here. So real, inverted, and diminished. So these two are the examples. This point and this point. These two are the examples. Real, inverted, and same size. This becomes the example. And then the third point, it is real, inverted, and enlarged. So this is also possible in these two cases. And fourth point is, it is also possible is, that is, it is virtual, erect, and enlarged. So this will be asked for you for 2 marks. Write the characteristics of the images which are formed in a concave mirror. The characteristics of the image which are formed in a concave mirror are real, inverted, and diminished. It may be real, inverted, and same size. It is real, inverted, and enlarged, virtual, erect, and enlarged. So these are the 4 possibilities when the object is placed. Possibilities of the image formed by a concave mirror when the object is placed at different distances from the pole of the mirror. So let us now get a total bird's eye view of the things what we had done in the previous class. So with that, so this was the thing done. So the object is kept at infinity. Position of the image is at principal focus. Nature of the image is real and inverted. Relative size of the image is highly diminished. So that's the point size image. So next is beyond the center of curvature. Between focus and center of curvature, the image is formed. It is real and inverted. It is diminished. This is the second image what I showed you. center of curvature, the image is formed at the center of curvature, it is real and inverted. So you can also write that is same size as that of an object. This is the size. So next the object is placed between the center of curvature and focus C and F. Then the image is formed between F and 2F or beyond C. So real and inverted, that is magnified. It's a magnified image. So when you keep the object at the focus, then the image is formed at infinity, because the two parallel light rays which come from the mirror after reflection are going to meet each other at infinity. So at that infinity also the image will be real and inverted. So it is highly magnified. It's a very big image. It's highly magnified. So this is very important and a very peculiar one. So between the pole and focus, when you keep the object, the image is found behind the concave mirror. It is virtual and direct and magnified. This is very, very important. Virtual and direct and also magnified. So this is the picture, not on the screen it is. It should be in your mind. Whenever you want, you should be able to recall this. And many questions are going to come on this. Many numericals are going to come on this particular criteria. So you have to remember this. Practice drawing ray diagrams. If you are very good in drawing ray diagrams, at any moment when asked, you will be very good at solving numericals. Right. So now, the next topic, we will be going with the uses of concave mirrors. Uses of concave mirrors. So among them, first one, concave mirrors are commonly used in torches, searchlights and headlights of vehicles to get powerful parallel beams of light. For example, if you take this as the headlight of a particular vehicle. So here inside this, let us take this. So this is the headlight. So inside this you will be having a concave mirror. Inside the headlight you will be having a concave mirror. So at the center you will be having an opening. So that is at the pole of the mirror they will adjust and keep a bulb at this point. This is the bulb. So if this is the pole of the mirror and this is the center of curvature, this will be the principal focus. This will be the principal focus. So for this mirror, this point will be the principal focus, where you will be having the filament of the bulb. The filament of the bulb is exactly placed at the focus of the mirror. So when the light comes out of the bulb, it falls on the mirror like this in different directions. It falls on the mirror. So usually you know that when light rays fall on a concave mirror is basically a converging mirror. So when the light rays pass through the focus to the mirror, the light rays starts traveling parallel to the principal axis. So this is the principal axis. They start after reflection, they start traveling parallel to the principal axis. This is the rule 1, what I told you regarding while drawing ray diagrams for concave mirrors. So when the light rays appear to pass through the focus of the concave mirror, after reflecting the mirror, they are going to travel parallel to the principal axis. So this is the parallel beam of light rays which is coming from the headlight of a vehicle, that is any vehicle, a bike or a car, whatever it is. So you can see here the headlights of the car. So you can see here that is the bulb, which is this one, which is placed here. So this is the principal, that is the concave mirror behind that. So you should very carefully place the bulb such that it should be at the focus of the concave mirror. So as the light ray starts coming from out of the bulb and get reflected on the mirror, it is in such a way that is arranged that the light rays coming from the focus of the principal focus of a concave mirror, after falling on the mirror, that start traveling parallel, so they become a parallel beam of light rays. So we can easily see the road in front of us. So in this, in the bulb you get two different filaments, one for deep and another is dim. So that's also works in the same manner. Here the light rays are made to bend like this. See, the same light rays are made to bend when the opposite, if any vehicle is coming, when you cannot see the road, then you can go for a dip of the headlight by changing some switch arrangements in your vehicle. So this is how steel, that is a searchlight or a headlight of vehicles or torches, they are going to work. So next. So second use of very important second use of concave mirrors is that they are used as shaving mirrors to see larger image of the face. So here it's very important. Just you should not remember what are the uses of concave mirrors through memory, just by hearting, recalling everything and just writing, getting 2 marks is that's not a big criteria here. Why particularly shaving mirrors are made of concave mirrors? Why? What is the reason? So that thing you have to understand the concept. So here they are used as shaving mirrors. So you can see here this is a concave mirror and the face of the person is in between the focus and the pole of the mirror. That's very important. So what I told you in the last diagram. So when this is the concave mirror here, right? This is the principal focus. So this is the principal focus here. This is the pole of the mirror. When the object is kept between principal focus and the pole of the mirror, one of the light rays is going to get reflected and passes through the focus. Another comes from the center of curvature of the mirror, that is we take it as something like this. So it is going to get reflected back. So when these two light rays, it appears as though they are coming from this point. So therefore the image will be formed at this point. So this was the 6th ray diagram we had drawn in the last class. In the same manner, scientific manner, these things work here. So here the object, the face of the person is placed in between the focus and the pole of the mirror. So a virtual image of the face is formed behind the mirror. In the mirror you are going to see your image as virtual and magnified. You can see here. So it's a small image here. Object is very small. When compared to the size of the object, the image is very big. So it is virtual. That is, it is erect and virtual, and also it is enlarged. So if your face is enlarged, then the process of shaving becomes easy. And a lady particularly, when she goes for a makeup, she can see her face better by using this concave mirrors. So concave mirrors are used as shaving mirrors and for makeup purposes. Okay. Dentists use concave mirrors to view large images of the teeth of the patients. So this is a very scientific thing here. So this is the teeth which the dentist has to see. ENT specialist especially to see the organs like ears, nose, throat. So and teeth. If they want to see it very clearly, they use this concave mirrors. So this is the concave mirror here. So the light somewhere from the source falls on the tooth and gets into the mirror here. So after reflection, light rays gets into the eyes of the dentist. So you can see the little bit magnified image of the teeth, so that you can give proper treatment. So you should at this particular point, one condition is that you should make the angle of incidence look equal to the angle of reflection at this point here. So this is the angle of, this is the normal what they have drawn. So this is the angle of incidence and this is the angle of reflection, and that should be equal for better view. So ENT specialists use this concave mirrors for better diagnosis. Okay. Next one. So very large concave mirrors are used to concentrate sunlight in order to produce heat in the solar furnaces. Solar furnaces are those devices particularly which are used to which use solar energy to produce heat, to heat metals, to whatever thing which is required to melt metals during metallurgical process. They use this. So it's a very big solar furnace. Furnace means it's a place where heat is produced. So using solar furnace means we're using solar light, that is sunlight, then we are going to produce a large amount of heat. So just imagine the light rays are coming from the sun, they are falling on a mirror here. So this is called as a heliostat mirror. So where it's a heliostat, helios means sun. So with respect to the sun, this mirror is placed here. As the sun changes its position, the position of the heliostat mirror also continuously goes on changing. So the light which falls on the heliostat mirror gets reflected to the concave mirror here. So this is the concave mirror situated here. So as the light rays from this particular mirror are traveling parallel to the principal focus of this mirror, they fall on the mirror. As the mirror is a converging mirror, all the light rays which fall on the mirror are concentrate at a particular point called as the focus. So the material what we have to melt or what we have to heat or the food materials where we have to cook them are placed at this particular point. So within very few minutes a large amount of heat energy is developed. So at this, as the temperature increases, the food easily gets cooked, or the metal what you have placed there gets heated up and it starts melting. So you can use the solar energy to produce large amount of heat energy by using the solar furnace. So inside the solar furnace, the main component which concentrates the heat of the sun is the concave mirror. So concave mirrors are used as a very important component in making solar furnaces. Right. So very large concave mirrors are also used. Okay. So next. Okay. So these are the very important 4 uses of concave mirrors. So in the next class I will be going with the convex mirrors. So in the first class I will be discussing regarding the characteristics and properties of concave mirrors, rules for drawing ray diagrams, some sign conventions I am going to discuss once again. Only 2 ray diagrams are in convex mirrors, so we will go with the uses also. So in the next class we will go with convex mirrors. Okay. So I hope you enjoyed the entire session. So please be updated, study day to day what all the things are there which is taught in your classes. Don't put it further, okay, let me do it tomorrow, don't do it like that. So day to day studies, you please do it. So in the coming Sunday we will be giving you a test on physics or until whatever the syllabus is completed. So please be ready with that. So notes for physics, it is sent to your WhatsApp. So please take it down and stay home, stay safe and keep learning. Thank you.